Finding the domain and range of a quadratic function. Any number can be the input value of a quadratic function. Therefore, the domain of any quadratic function is all real numbers. Because parabolas have a maximum or a minimum point, the range is restricted. Since the vertex of a parabola will be either a maximum or a minimum, the range will consist of all y values greater than or equal to the y-coordinate at the turning point, or less than or equal to the y-coordinate at the turning point, depending on whether the parabola opens up or down. Domain and range of a quadratic function. The domain of any quadratic function, again, is all real numbers unless the context of the function represents or presents some restrictions. The range of a quadratic function written in general form, f of x is equal to ax squared plus bx plus c, with a positive value is f of x greater than or equal to f of negative b over 2a, or that value, meaning that's the y value to infinity, and you're including it. Now, the range of a quadratic function written in general form with a negative value would then be, because if it's less than or equal to, you would have parentheses negative infinity, and then the value of k with a bracket. Now, the range of a quadratic function written in standard form, f of x, which is equal to a times x minus h squared plus k, with a positive a value, is f of x is greater than or equal to k, and the range of a quadratic function written in standard form with a negative a value is f of x less than or equal to k. Now, given a quadratic function, we want to find the domain and range. Number one, we want to identify the domain of any quadratic function as real numbers. Number two, determine whether a, the number at the beginning or the leading coefficient, is positive or negative. If a is positive, then the parabola has a minimum. If a is negative, then the parabola has a maximum. Then we're going to determine the maximum or the minimum value of the parabola k. And then if the parabola has a minimum, then the range is given by bracket k to infinity. If the parabola has a maximum, then the range is given by negative infinity to k with a bracket. Example 4, find the domain and range of a quadratic function. Find the domain and range of f of x, which is equal to negative 5x squared plus 9x minus 1. As stated above, it says that with any quadratic function, the domain is all real numbers unless there is a specific restriction. In this problem, we don't have a restriction, so therefore we can say that the domain is the set of all real numbers. Now, we need to take a look at the value of a. So we can see that a is negative. So the parabola is going to open downward and therefore is going to have a maximum value, again, according to the definition. So we need to determine the maximum value, and then we can begin by finding the x value of the vertex. So for step 1, we can see that the value of a is negative 5. We can see the value of b is positive 9. And we can see that the value of c is negative 1. So we're going to find h. So h is equal to negative b over 2a. And so therefore h is going to equal negative 9 over 2 times negative 5, which makes this negative times a negative is a positive. So h is going to equal 9 over 10. So the first part of the vertex, the x-coordinate is 9 over 10. Now, in part 3, we need to say, okay, well, k is equal to f of h. And recall that h is 9 over 10. So we're going to replace h to be the value of 9 over 10 into that function. So we have negative 5 times 9 over 10 squared. So that becomes negative 5 times 81 over 100. Plus 9 times 9 is 81 over 10. Plus 1 over 1. Now, if we take negative 5, and you can see that we have 100, we can simplify that to negative 1 over 20, which is negative 81 over 20, plus we need to find a common denominator between 10 and 1 and 20. So the common denominator, we know that's 20, so 10 times 2 gives you 20, so 81 times 2 gives you 162, 1 times 20 is 20, so therefore 1 times 20 is 20. So if we combine all three of these fractions, we get the value of k to be 61 over 20. So now we know that h is 9 over 10, we know that k is 61 over 20, and that is the vertex. Now, we can also determine that from this, we can see that the value of k is going to represent the maximum value because of the fact that the parabola is opening down. So that means we have a maximum. So the maximum value is at 61 over 20. Now that the maximum value is 61 over 20, then we can then write the range is parentheses negative infinity to 61 over 20 with a bracket. And now let's see what this graph looks like when we graph this in Desmos. So again, the function is negative 5x squared plus 9x minus 1. So we have negative 5x squared, and that's plus 9x, plus 9x minus 1. Okay, and there is our vertex. There's our x-intercepts, and there's our y-intercept. So let's go ahead and copy and paste this. So if we take a look at this graph, okay, again, the vertex we can see here is 0.9. Well, let's just verify that in our vertex. Well, that means that our vertex, beginning part of our vertex, was 9 over 10. So 9 over 10, we know it's going to give us 0.9, right? And then 61 over 20 gives us 3.05. And so we can see it also crosses the x-axis at those two x-intercepts, and we have a y-intercept at 0, negative 1. So now, just to verify what our range is in this particular problem, you can see that the maximum occurs at 3.05. So there is the maximum with the bracket, and that's going all the way starting at negative infinity. And that's how we're getting the range here.